Hi, welcome to part 2 of this series. Today, I'll fix a door issue from the last video. I'll also show you a few new door systems. And by the way, the project file is on Google Drive, so you can download it and try it yourself. I'll try not to over-explain things this time, so just follow along with me. If I already covered something in the last part, I won't go over it again. And if you have any questions, feel free to ask in the comments. First of all, we need an enumeration. This will help us keep track of the door's state at all times. To create one, just right-click in the content browser, go to Blueprints, and choose Enumeration. The enumeration you just created. Add 5 different door states. We'll need the locked state in a future door system, but it's better to add it now. Next, we create a new blueprint. Choose Actor as the type. Then, add the door's static mesh and a box collision component. To use the enumeration we created, add a new variable inside your blueprint. Then, search for the name of your enumeration and set it as the variable's type. We use the boxes begin overlap and end overlap events to enable and disable input. This way, the key input only works when the player is inside the box. Now, select the key you want to use. Get the door state variable and add a switch on enum node. From the drop-down list, choose the enumeration you created earlier. It will appear with the name you assigned. Add a timeline node to control the animation or logic over time. Inside the timeline, create a new track. Add 2 keys to it, one with a value of 0 and the other with a value of 1. You can set the time between them however you like. This controls how long it takes to go from the first key to the second. Here, I set it to 0.5 seconds. Now here comes the important part of this video. How the door opens depending on the player's position and angle. Create a new function for this. Add a new variable of type float and use nodes like I do inside the function. And use this function here. From the direction pin of the timeline, drag out and use the switch on eTimeline Direction node. This node checks whether the timeline is moving forward or backward, so you can change the door's state based on that. At this point, the door might not work correctly. That's because we forgot to set the enum values to opening and closing on the second output of the sequence node. Also, don't forget to set the default value of the door state variable to closed. And that's it. For our second door, which is locked and only opens with a switch, just duplicate the first door blueprint. Then, right after the F key node, add a branch to check if the door is locked. If it's locked, the condition will be true. And since we connected the logic to the false output, nothing will happen while the door is locked. Once the door is unlocked, the condition becomes false, and the input will go through. So the door will work as expected. Now, create a blueprint switch, also based on the actor class. It's very simple, so no need for further explanation. Our switch is working now. Next, we need a way to send the unlock message from this blueprint to the other one. For that, we'll use a blueprint interface. After creating it, open the interface and rename the existing function to unlock. Now, go to your door blueprint, select Class Settings, and in the Details panel, click Add. Under Implemented Interfaces, find and add your blueprint interface. After adding it, a new section for your interface will appear on the left panel. Double-click the interface, and it will automatically add the event to your event graph. From the event's output, set the door state variable to closed. This means when the switch message arrives, the door state changes from locked to closed. Now go back to your switch blueprint. From your timeline's finished output, add a getActorOfClass node. Then, find the unlock message from the return value. If you don't see it, make sure context sensitive is checked. It should be the same function name you set in the interface. Also, the door still isn't working correctly because I accidentally connected the branch node after the F key the wrong way. We need to connect the false output instead. For the third door, we're going to create a system similar to the gate doors you find in many old puzzle games. For this door, we need to add a new function called Closing to the Blueprint Interface. Now, create a simple blueprint that sends two messages: unlock when the player is inside the box and closing when the player leaves. Now create the door blueprint just like I did. Now, set the actor classes inside the switch blueprint to your doors. Connect the unlock interface event to play and the closing event to reverse. But as usual, the doors don't work yet because I mistakenly used the static mesh instead of the box collision for the begin and end overlap events. Finally, this part is very simple, but I just wanted to show you how you can control a door using physics. Here's how it works. At first, physics is disabled, and when you enter the nearby box, physics gets enabled again. Now, using these simple doors, you can create much more complex doors with multiple functions. And that's it for today. Thank you so much for watching the video till the end. If you noticed any mistakes or have questions, please let me know. And if you liked it, don't forget to like and subscribe.